Before the first stars ignited, before galaxies took shape, before light had structure, something left a trace. It wasn't a flash of light. It wasn't a cosmic explosion. It was a whisper, a signal detected in our modern era, but originating from a time when the universe was, by all accounts, dark and lifeless. For decades, we believed this era was a closed book, a missing link in the history of everything. We called it the Cosmic Dark Ages, a period so cold and so empty that no telescope could ever hope to see it. But in 2018, in a remote desert in Western Australia, a small radio antenna, no bigger than a dinner table, picked up a heartbeat from the void. It should not have been visible. It should not have survived 13 billion years of cosmic expansion. And yet, there it was, striking the metal of an antenna in the red dust. This isn't just a story about a discovery. It's a story about why our maps of the universe might be fundamentally wrong. This is the mystery of a signal older than the stars. To understand the weight of this signal, we have to travel back. Roughly 380,000 years after the Big Bang, the universe reached its first great milestone. It cooled enough for the first atoms to form. Light, once trapped in a hot plasma fog, was finally set free. This was the first light, the cosmic microwave background. We can still see it today. But then, the lights went out. For the next several 100 million years, the universe entered the Dark Ages. This wasn't darkness like a night without a moon. It was chemical silence. There was only hydrogen gas drifting through the blackness. Gravity worked quietly in the background, pulling dark matter into invisible webs. But there were no stars to burn, no oxygen to breathe, no heavy elements to build worlds. Cosmologists knew this era had to exist. It is the bridge between the Big Bang and everything we know. But for a long time, we assumed it was observationally inaccessible. After all, how do you photograph a shadow in a room with no windows? Enter the edges experiment. To hear a whisper from 13 billion years ago, humans had to find the quietest place on Earth. In this part of the outback of Australia, radio silence is the law. No cell phones, no Wi-Fi, no modern interference. Here, a team of researchers set up a simple metal structure. They weren't looking for a glow, they were looking for a dip. Think of the cosmic microwave background as a giant backlight, a screen behind the universe. As that light passed through the cold hydrogen of the Dark Ages, the gas absorbed a tiny specific sliver of that light at a wavelength of 21 centimeters. In 2018, the team reported they found it, a fingerprint of the Dark Ages. The timing was perfect, roughly 180 million years after the Big Bang. That alone was a triumph, but as the researchers looked closer, the triumph turned into a crisis. The dip was too deep, nearly twice as deep as every physics model predicted. In the language of thermodynamics, this means the hydrogen was too cold, far colder than the surrounding radiation. It was as if you walked into a room with a furnace running, but found a block of ice that refused to melt. According to standard physics, this shouldn't be possible. The early universe was cooling faster or differently than our laws of nature allow. When the numbers don't work, we are forced to question reality. To make the numbers work, one of three things must be true. First, our understanding of hydrogen, the simplest atom in existence, is incomplete. Perhaps it was cooling more efficiently than we thought. But if we don't understand hydrogen,
the foundation of cosmology begins to crack. Second, the background radiation was different. Perhaps there was an unknown source of light in the early universe that we completely missed. Or third, and most provocative, an unknown interaction was stealing heat from the system. Many theorists believe this could be the first real evidence of dark matter interacting with normal matter. Imagine dark matter particles brushing past hydrogen atoms, quietly siphoning away energy, like a cosmic heat sink. This isn't just a tweak to a theory. If this signal is real, we aren't just missing a piece of the puzzle. We may be looking at a different puzzle entirely. The signal presses directly against the foundations of early universe physics. So, where does that leave us? This signal has not yet been independently confirmed. Some scientists argue it could be an error, interference from the red soil of the desert, or from our own technology. We are waiting for the next generation of radio telescopes. Some are even proposed for the far side of the moon, shielded from Earth's noise entirely. They will tell us whether this whisper was real or an illusion. But one thing is certain. The universe left a measurable trace from a time before stars existed. That trace survived billions of years of cosmic evolution, through the birth of galaxies and the deaths of suns, just to reach a small antenna in a silent desert. That isn't mystery for entertainment. That is mystery as evidence. Some discoveries shout, others whisper. This one does not demand your belief. It demands your attention. Because in that cold, dark silence, the universe may be telling us how it truly began. If you want to follow what we know, what we don't, and where the universe quietly resists explanation, this is Beyond the Void.